multiplying radical expressions. So, for example, if I'm given 8 minus square root of 5 times 9 minus square root of 2, just like in the past sections, we can FOIL these binomials. So I say 8 times 9 is 72. First outer, 8 times square root of 2 is minus 8 square roots of 2. It times this to the front. Inner, minus 9 square roots of 5. Last, remember, because they have the same power for their, and the root is the same, we can times the two numbers inside and get plus square root of 10. Can this simplify at all? No, nothing combines together, so that would be my final answer. Square root of 7 plus square root of 5, square root of 7 minus square root of 5. Right off the bat, something to note. These are conjugate pairs. First, square root of 7 times square root of 7, square root of 49. Square root of 7 times square root of 5 is negative square root of 35, plus square root of 35 minus square root of 25. So remember, with the conjugate pairs, the middle term cancels out. This will always happen. Square root of 49 is 7, minus square root of 25 is 5, and 7 minus 5 is 2. Square root of 15 minus 4 squared is square root of 15 minus 4 times square root of 15 minus 4. First, square root of 15 times square root of 15 cancels the square root. It's going to be 15. Minus 4 square roots of 15 for the outer, minus 4 square roots of 15 for the inner, plus 16 for the last. So 15 plus 16 is 31. Negative 4 and negative 4 makes negative 8 square roots of 15. Eight plus the cube root of 5 times 8 minus the cube root of 5. Conjugate pairs once again. So we're actually going to cut right to what you can do. We're going to do the trick on this one. Because they're conjugate pairs, you just need the first two times together to make 64, and the last two times together to make the cube root of 25. If you don't remember this trick, FOIL the whole thing out. Your middle term will always cancel. You'll always get the same answer. So the shortcut, it's actually better to do longhand and cancel than to miss something with a shortcut. But just so you're aware, it's an option. If I have the square root of m minus the square root of n, square root of m plus the square root of n, conjugate pairs once again, but we'll show how these cancel this time. M and m cancels the square root, plus square root of mn minus square root of mn minus n. Inside are opposites in sign, but the same number, so they cancel. So I get m minus n.